Okay, so I'm doing this one from an article because my videos are going to be both a combination of what I know from memory and stuff from articles. So this one's from an article, the last one was from memory. And this one's also about subduction zones. So here goes nothing. Subduction zones occur at collision boundaries where at least one of the colliding lithospheric plates contains oceanic crust. In accord with plate tectonic theory, collision boundaries are sites with lithospheric plates move together, and the resulting compression causes either subduction, where one or both lithospheric plates are driven down and destroyed in the molten mantle, or crustal uplifting that results in orogeny, mountain building. Subduction zones are usually active earthquake zones. Subduction zones are the only sites of deep earthquakes. The areas of deep earthquakes, ranging to a depth of 415 miles, 670 kilometers, are termed Benioff zones. Deep earthquakes occur because of forces due to plate drag and mineral plate phase transitions. The release of forces due to sudden slippage of plates during subduction can be quick and violent. Subduction zones can also experience shallow and intermediate depth earthquakes. Oceanic crust is denser than continental crust and is subductible. Moreover, as oceanic crust-bearing plates move away from their site of origin divergent boundaries, the oceanic crust, the cooling results in an increase in general density of the oceanic crust. The concurrent loss of buoyancy makes it easier to subduct the crust. In addition, colliding plates create tremendous force. Although lithospheric plates move very slowly, the plates have tremendous mass. Accordingly, at collision, each lithospheric plate carries tremendous momentum, the mathematical product of velocity and mass, that provides the energy to drive subduction. In zones of convergence, including subduction zones, compressional forces, i.e., compression of lithospheric plate material, dominates. Earth's crust is fractured into approximately 20 lithospheric plates. Lithospheric plates move on top of the asthenosphere, the outer plasticity deforming region of Earth's mantle. Because Earth's diameter remains consistent, there is no creation of destruction of lithospheric plates. Each lithospheric plate is composed of a layer of oceanic crust or continental crust, superficial to an outer layer of the mantle. Oceanic crust is composed of high-density rocks such as olivine and basalt. In contrast, continental crust is composed of lower-density rocks such as granite and andesite. Within subducting zones, oceanic crust can make material contributions of lighter crustal materials to overriding continental crust. As the oceanic crust subducts, parts may be scraped off to form an accretion prism. Rising material at sites where oceanic crust subducts may form island arcs. When oceanic crust collides with oceanic crust, both subduct to form an oceanic trench. Example, the Marianas Trench. Dual plate subduction can result in ocean trenches with depths approximating 38,000 feet. When oceanic crust collides with continental crust, the oceanic crust subducts under the lighter continental crust. The subducting oceanic crust pushes the continental crust upward into mountain chains, example the Andes, and may contribute lighter molten materials to the overriding continental crust to form volcanic arcs, example the Ring of Fire, a ring of volcanoes bordering the Pacific Rim. Because continental crust does not subduct, when continental crust collides with continental crust, there is an uplift of both crusts. At trouble points where three plates converge, the situation becomes more complex, and in some cases, there is a mixture of subduction and uplifting. Convergent boundaries are, of course, three-dimensional, because Earth is an oblate sphere. Lithospheric plates are not flat, but are curved and fractured into curved sections akin to the peeled sections of an orange. Convergent movement of lithospheric plates can best be conceptualized by the movement together of those peeled sections over a curved surface. Subduction zone, large-scaled narrow region in the Earth's crust, where according to plate tectonics, masses of the spreading oceanic lithospheric bend downward into the Earth's along the leading edges of converging lithospheric plates, where it slowly melts at about 400 miles, 640 kilometers deep, and becomes reabsorbed. Subduction zones are essentially marked by deep oceanic trenches that often exceed 6 miles, 10 kilometers, compared to the ocean's overall depth of 2 to 4 miles, 3 to 5 kilometers. A pattern of earthquakes or shallow, intermediate, and deep focus occurs along the same angle as the descending plate, which is steeply inclined 30 degrees to 60 degrees toward the continent behind the trench in a zone called the Benioff Zone. Discovered by the U.S. seismologist Hugo Benioff, the earthquake pattern enables geophysicists to trace the descending plate to depths of 600 to 700 kilometers, 370 to 440 miles, where temperatures are thought to be between 1,000 degrees Celsius and 2,000 degrees Celsius, 1,800 degrees Fahrenheit and 3,600 degrees Fahrenheit. As the oceanic plate descends, friction between the two plates probably causes partial melting of the descending plate, forming a magma of andesitic composition that rises along fractures. If the overlying crustal plate is oceanic, the magma may erupt to form island arcs such as Japan or the Aleutians. If the overlying plate is continental, a line of batholiths and volcanoes may be created, as in the Coast Ranges of Canada and the western United States. Okay, guys, I'm sorry if I messed up a little, because some of the words in there are kind of hard to pronounce for me, so I did my best. That's like third year college level reading, so it's a little hard. I read at like first year college level, so that was a little hard, but I hope you enjoy it. Thanks, bye.